Imagine running a model with Opus 4.6 level coding performance at home on a graphics card with only 6 GB of VRAM. That sounds impossible. But users have already run the previous Qwen 3.8 35B-A3B on 6 GB GPUs at around 20 tokens per second. They did it by keeping most of the model in system RAM and letting the processor handle the parts the graphics card could not hold. Now the name Qwen 3.8 35B-A3B has appeared inside a popular inference repository. Screenshots spread across X, and within hours, people believed Qwen was preparing a much faster alternative to its new 27B model. And that 27B is a model Qwen's own coding benchmarks place near, and sometimes above, Claude Opus 4.6. Then, the name was removed. The change was labeled a correction for the wrong model IDs, and Qwen has still not announced a 35B-A3B version. So this could have been nothing more than a typo. But the reaction reveals something more important. This is the model many local AI users actually want. In this video, what appeared on GitHub and why it disappeared. Then, whether a model like this could really run with only 6 GB of VRAM, and how close it could get to Qwen 3.8 27B. Because the leak may not be real, but the idea behind it makes a lot of sense. The story began inside MS Swift, an open-source framework maintained by ModelScope for training and deploying large AI models. A model entry appeared with the name Qwen 3.8 35B-A3B. That was enough to get the community's attention. Posts on X quickly described the model as almost confirmed, and people began discussing whether it could run with 6, 8, or 16 GB of VRAM. But there were two problems. First, this was not an official Qwen announcement. The name appeared in MS Swift, not on Qwen's model page or blog. Second, the name was removed shortly afterward. A follow-up change called Fix Wrong Model ID replaced the 35B-A3B name with the already released Qwen 3.8 27B. So the most likely explanation is simple. It was a typo, not a real leak. As of now, there are no official weights, no benchmarks, no specifications, and no release date. So we should not call this model confirmed. But that does not mean the story ends here. Qwen 3.8 27B is a dense model. When it generates a token, it uses all 27 billion parameters. That can produce impressive results, but it also demands a lot from the hardware. Even at 4-bit quantization, the model itself takes roughly 14 GB. And the context and the cache need even more memory on top of that. A 24 GB GPU gives the model enough breathing room. On a 12 or 16 GB card, users may need stronger compression, a shorter context, or help from the CPU, and each of those choices makes the model slower or reduces its quality. A 35B-A3B model would take a different approach. The 35B would represent the model's total parameters. A 3B would mean that only around 3 billion parameters are activated for each token. Instead of using the entire model every time, a mixture of expert system chooses a small group of specialized experts for the current token. The whole model still needs to be stored somewhere, but far less of it is actively processed at once. That can make generation much faster, especially for coding agents, tool use, and servers handling several users at the same time. This is why the community is asking for more than simply a smaller Qwen. They want the capability of a large model with the speed of a much smaller one. One request on Qwen's Hugging Face discussion page received hundreds of reactions. Another community post asked for not only a 35B, A3B, or A5B model, but also a 9B and a 120B with 10 billion active. The demand is clear. The 27B model is powerful, but it does not fit every local setup. If you want Qwen to release a smaller or faster 3.8 model, tell me in the comments which version you would choose, the 9B, the 35B, A3B, or the 120B. The biggest reason a Qwen 3.8 35B, A3B seems possible is simple. Qwen already released almost exactly this format in the previous generation. Qwen 3.6 35B has 35 billion parameters in total, but activates only 3 billion for each token. It supports images, has a native context window of 262K tokens, and uses only a small group of its experts for each token. It was also trained with multi-token prediction, the same feature that can accelerate Qwen by predicting several tokens ahead. And this was not just an efficiency experiment. It scored around 73 on SWE Bench Verified and just over 51 on Terminal Bench 2.0. On Terminal Bench, it even outperformed the dense 27B model from the same generation. That does not prove a Qwen 3.8 version exists, but it shows that Qwen has already released this kind of efficient architecture before. The obvious question is whether Qwen can bring the improvements from 3.8 into the same efficient format. If it can, a 35B-A3B version could matter more to local users than the larger flagship models. This is where the A3B name can be misleading. 3 billion active parameters does not mean the model occupies the same memory as a normal 3B model. All 35 billion parameters still need to be stored, in VRAM, in system RAM, or both. Based on similar 35B models, a 4-bit version would likely need around 20 GB before adding a large context. That means a 24 GB GPU would probably be the comfortable single GPU option. On a 16 GB card, more aggressive quantization could make it possible, but context length and quality become part of the trade-off. And yes, this type of model can run with a 6 GB GPU, but not inside 6 GB of VRAM alone. One community member ran Qwen 3.8 35B-A3B on a GTX 1060 with 6 GB of VRAM and 32 GB of system RAM. With most of the experts handled by the CPU, it reached around 19 to 20 tokens per second. Another user reached roughly 23 tokens per second on a laptop RTX 2060 with 6 GB of VRAM and 24 GB of system RAM. Those results are impressive, but the system RAM and the CPU are doing much of the work. The GPU alone is not holding the entire model. Apple Silicon systems could also be a good match. A Mac with 32 or more gigabytes of unified memory may have enough space for useful quantization, although there, speed would depend on memory bandwidth and runtime support. The important advantage would not be a dramatically smaller file. It would be faster generation from activating fewer parameters for each token. Until Qwen publishes the model, no one can provide real benchmark numbers, but Qwen 3.8 27B gives us an idea of why people are excited. In Qwen's own results, the 27B model scored 61.7 on SWE Bench Pro, compared with 53.4 for Claude Opus 4.6 Max. It also reached 73 on Terminal Bench 2.1. That does not mean Qwen 3.8 27B is equal to Opus 4.6 at everything. These are Qwen's own benchmark results, and broader independent testing is still needed. But it does show that this small local model can reach former frontier-level coding performance on some difficult tests. Now imagine keeping most of that capability while activating only 3 billion parameters for each token. That is the real promise of Qwen 3.8 35B-A3B, not simply a smaller model, but a much faster version of one of the strongest local coding models available. To deliver that promise, it would need to do 4 things. First, it would need to retain most of the 27B model's coding and reasoning ability. A faster model is not useful if the quality falls too far. Second, it would need strong support in llama.cpp, or Llama, LM Studio, VLLM, and SGLang. MoE models can behave very differently depending on how well the runtime handles their experts. Third, it would need compatible quantizations and MTP support. Fewer active parameters plus multi-token prediction could make coding agent workloads especially fast. And finally, it would need enough memory efficiency to offer a meaningful advantage on 16 and 24 GB systems. If Qwen achieves those 4 things, this could become one of the most practical local coding models for consumer hardware. Not because it is the smallest, but because of the balance between quality and speed. Right now, the honest answer is, we do not know. The GitHub entry is weak evidence. It was removed, labeled an incorrect model ID, and never supported by an official Qwen announcement. But the model itself is completely plausible. Qwen released a 35B-A3B in the previous generation, and the community is asking loudly for a new one, and the current 27B dense model leaves a clear space for a faster MoE alternative. So, there are 2 separate conclusions. No, the deleted GitHub name does not confirm Qwen 3.8 35B-A3B. But yes, a model like this would be a logical next release, and perhaps the most important Qwen 3.8 model for local users. For now, watch the official Qwen pages, not just screenshots on X. If real weights, a model card, or another credible reference appears, I'll cover the hardware requirements and test it against Qwen 3.8 37B. Subscribe if you want to see that test when the model actually arrives. The leak may have disappeared, but the demand for a faster, more accessible Qwen has not.